Alright, we're looking at square root functions again today. We have square roots on both sides, so again we want to isolate for x, so we're going to square both sides. When we square, the square roots cancel out and we get 3x is greater than x plus 6. Now once again we're solving for x, so let's subtract x right here. We get 2x is greater than 6, so x is greater than 3. Alright, now we have two different functions, so let's check our domain restrictions for both of those, right? So we have 3x is greater than 0, so we know that x is greater than 0 for my square root of 3 function, sorry, square root of 3x function, excuse me. Okay, so we know that that is going to start at, my starting point is going to be at the origin, okay, because we don't have a vertical or a horizontal transformation. However, we do have a horizontal compression, right, because we have a 3 inside my square root. So my square root of 3x function would look like this right here. Now we're looking at our domain restriction for the other one. So we're going to set x plus 6 greater than 0. So we get x is greater than 6. Sorry, negative 6, excuse me. So we know that this has a starting point at negative 6. Okay, because we went left 6 units for my horizontal transformation. Now this function is going to look like that. So we have the square root of 3x looks like this. We have the square root of x plus 6 looks like that puppy. Now we want to figure out when is the square root of 3x function greater than the square root of x plus 6 function. Okay, well at the point 3 and then on to infinity. Alright, so if I was to write that as an interval, that would be from 3 to infinity. Now, one thing wrong here, it's not going to be a bracket. Why? Because look at my inequality symbol. It is not equal to. So we're looking at that right there. So when x is greater than 3 all the way to infinity is when my square root of 3 function is greater than my square root of x plus 6 function. Moving on to number 2, same process we want to solve here. So we're going to square both sides. Square both sides, so we get 2x plus 1. Now I'm going to square this. So this is the square root of x plus 1 times the square root of x plus 1. So when I FOIL this out, I'm going to get x plus 2 square roots of x plus 1. Alright, now again we're solving for x, so I need to get the x's on the same side, so let's subtract x here. We get x plus 1 is greater than or equal to 2 square roots of x plus 1. Alright, now we're going to subtract our 1 here. X is less than or equal to 2 square roots of x. Now let's get rid of our square roots, so we need to square both sides. So now we're there. Now let's get our x's on the same side. So we get x squared minus 4x is less than or equal to 0. So we can factor that into this. So we have x equals 0 is a solution, and we have x minus 4 equals 0. So we get x equals 4 as a solution. So we have two solutions at 0 and at 4. Okay, so if I'm going to graph this, we need to look at our domain restrictions. So we set this equal to, greater than 0. So 2x plus 1 greater than 0 for the first domain restriction. So we can see if we subtract 1 on both sides, excuse me, okay, we get x is greater than negative 1/2. So we know that this function, square root of 2x plus 1, okay, looks like this puppy right here. We have our domain restriction at negative 1/2. Okay, so it's going to be just a little bit over here. All right. We know that we have our intercept, okay, at negative 1. We have a horizontal compression. All right, looking at this one, we know we have a vertical shift. So we went up 1 unit, okay, and it's a square root function. So it would look like this, something like that. All right, so now we want to figure out when is this, all right, sorry, let me label them. When is this function less than or equal to this function? Okay, what's less than or equal to from this point to this point? So between these 2 points. Okay, between these 2 points. Okay, so if I wanted to write that in interval notation, it would be less than or equal to, so we know we have a bracket between 0 and 4. All right, moving on to number 3. Number 3 is the same type, right? Again, we're going to square both sides. Oops, sorry. Less than. Okay, and we get x plus 1 plus 4 square roots of x plus 1 plus 4. All right, so again, that's 2 of those, so I just FOILed that out and got that right there. Now again, we're solving for x. Okay, so I get 2x minus 4. Okay, I move the 1 over, I move the 4 over, I move the x over. So we get 4 square roots of x plus 1. Now again, we're solving for x, so I need to square both sides. Actually, sorry, just divide by 2. Okay, because those are both divisible by 2, so those cancel out. We get x minus 2 is less than 2 square roots of x plus 1. Alright, now let's go ahead and square both sides. So we get x squared minus 4x minus 4 plus 4, excuse me, is greater than 4x plus 1. Alright, now if we were to go ahead and distribute this, x squared minus 4x plus 4 is greater than 4x plus 4. Fantastic. Let's get our x's on the same side. So let's subtract 4x. Let's subtract 4. We get x squared minus 8x is less than 0. We can factor that into x. X minus 8 less than 0. So we know x equals 0 and x equals 8. Alright, so now let's check our domain restrictions for our functions. So we've got the first one, 3x plus 1 is greater than 0, so we get x is greater than or equal to negative 1/3. Second one, x plus 1 greater than or equal to 0, so x is greater than or equal to negative 1. Alright, so if we were to graph both of these functions, we're to graph this, we know we have a vertical translation up 1 unit, and we have a horizontal compression. So we're going to translate it up 1 unit and a horizontal compression, so at negative 1/3. Look kind of like that right there. Alright, we know that this one, okay, we're going to go up 2 units and we're going to go left 1 unit. So left 1 unit, but up 2 units. Starts right there. Okay, but that is going to be a lot flatter than my other function. Sorry, there we go. Okay, and then we have that function, 3x plus 1. Rock on. Alright, so now we need to figure out when is this function less than this function. Okay, this function is less than that function all the way up until that point. Alright, so between my starting point, which is my starting domain restriction at negative 1/3, all the way up until, that would include 0, right, because it's still less than, all the way up until 8. At my second point, those cross, and my other function becomes greater. Looking at number 4, again, we want to square both sides. 5 minus x is greater than x plus 1. Let's get our x's together. So let's add x, subtract 5, so we get 0 is less than 2x. Let's subtract 1. 4 is less than 2x, divide by 2, so 2 is less than x. Or I could say x is greater than 2, same thing. So let's check our domain restrictions. First one, we got 5 minus x is greater than or equal to 0. Subtract 5, so x is less than or equal to 5. Okay, what I did is I divided by a negative 1, so that means the inequality sign has to flip, and that becomes positive. So x is less than or equal to 5. My second domain restriction, I've got x plus 1 is greater than or equal to 0. X is greater than or equal to negative 1. Alright, let's graph this, 5 minus x. If I was to graph that, okay, I can know that I have a vertical reflection, okay, and we went 5 units to the right. So it would look like that. If I was to graph this, I know I went 1 unit left. Okay, and it would look like that. So we have square root of 5 minus x, and we have the square root of x plus 1. Alright, now I need to figure out when is this function less than this function. Well, it's between these 2 points, right? So between my point of intersection would be at 2, okay, and then all the way until my domain, I guess you could say, stops, not starts, because it's a vertical reflection. So between 2 and my domain stopping, which would be at 5. So between the points 2 and 5. Now they're both parentheses. Why? Because of that inequality symbol there. Actually, let's check that, because it does actually touch at that point, because that's where the domain starts at. Duh. There you go. That makes sense. Alright, last one. We're squaring both sides. And we get x minus 8 square roots of x plus 16 greater than or equal to x. So again, we're solving for x. So we get 16 is greater than or equal to 8 square roots of x. We'll square both sides, or sorry, we'll divide by 8 because they're both divisible by 8. So we get 2 is greater than or equal to square roots of x. Now let's square both sides. So x is less than or equal to 4. X is less than or equal to 4. Alright, let's check our domain restriction. So we get the square root of x is greater than or equal to 0. So x is greater than or equal to 0. Okay, same thing over here. Domain restriction would be the square root of x is greater than or equal to 0. So x is greater than or equal to 0. So if I was to graph this function, I have a vertical translation down 4 units, square root of x. This one starts at the origin. It's the parent function, square root of x. Okay, so this is the function, square root of x minus 4. This is the function, square root of x. So I need to know, when is this function greater than this function? Okay, well, there is no solutions. This function is never greater than that function. No solutions. No solutions.